In this video, I'm going to find a solution of this nonlinear equation. X multiplied by exponent of minus x is equals to 0.2. So to do that, I'll start by entering the code there. So I'll go on my live editor and then click on code. At the first step, I define a symbolic variable syms or the symbolic variable x there. To find the solution of this nonlinear equation, I start by rewriting that equation there in a standard form, so that I'll call the function f is equals to then x multiplied by exponent open parenthesis minus x then minus 0.2. So when you write it in standard form, we have all the things on one side. So I put the 0.2 there to the left there. So it becomes minus 0.2. I can just run to check if I've entered it correctly. So f is equals to x multiplied by exponent of minus x minus 1 over 5. The 1 over 5 is the one that simplifies to minus 0.2. So what we need to find the root of this nonlinear equation, we need to get the approximate values where the graph of f of x crosses the x-axis. So to see that graph, we can use the function fplot. So I can go on and use the function fplot, open parenthesis. So I'm plotting the function f that I've just defined here. Then I specify the domain there. So I can just plot it from 0, let's say, to 10. So I can go on and run. So this is the graph that we are having. But to see where it crosses the x-axis, which is this line here, what I can do, I can just click on this graph here, then go on to where it says grid here. So we now have the grid. We can now see this line x equals to 0. So the values that we are looking for are the lines where this curve here is crossing this line x equals to 0. So what we can see there, the first one is a value is closer to 0 but less than 2. And the other one here is greater than 2 but less than the 4. So to get those values, what we need to go on and do is use the function f0. So for the first value, it will be x1 is equals to f0, then open parenthesis, then open a single quote, then type in the function there. You say it's x multiplied by exponent of open parenthesis minus x, then close my parenthesis, then minus 0.2. Then we'll put a comma. Then we put a value which is closer to the ones that we are looking for. So here a value which is greater than 0 but less than 2. We can try a value, say 0.5. That's a value that's closer there. So the f0 will give us the exact value of where this curve crosses the x-axis. So I can then go on and run. So we have the value of the x1 there is 0.2592. I can then go on and look for the other one now. So for the other one, we are now looking at the one which was greater than 2 but less than 4. So what I can do is I can just go on and copy this command that I entered earlier. So I copy it and then paste it here. And now I'm changing to find the second value. So for the second value, we are saying f0 is still the same function, but now we are looking at the value which is the greater than 2. Let me say take 2.5. Then I go on and run. So we have the x2 is 2.5426. So the roots of this nonlinear equation are x1 is equal to 0.2592 and the other one is 2.5426.